Be something that's totally new to you. You probably calculated simple interest and for some reason somewhere in another math course. So simple interest as opposed to compound interest. Simple interest is oftentimes used for loans that are taken out at a credit union. Credit unions very often do simple interest for things like a car loan, a personal loan, or something like that. Simple interest does not apply to credit cards. It doesn't apply to mortgages. It doesn't apply to loans taken out at most other banks. Banks usually use compound interest. The difference between the two is that if you can get a loan at simple interest, you actually will probably be better off because your simple interest will be charged all up front and then it's just split over all of your payments. Whereas if you're charged compound interest you get charged on the balance you owe at that very moment. And then you make a payment, it reduces the amount you owe a little bit, but part of that money that you made your payment for went to interest, so it doesn't reduce as fast. The advantage to having a compound interest loan is if you're taking out a loan and you think that you're going to be able to pay it off early, or if you think you're going to be able to make maybe a bigger payment every month, which will pay it off faster. But if you can get a simple interest loan, then that's usually the way to go if it's a short-term loan. So how do we calculate simple interest? Simple interest is based upon something called a principal. The principal is also referred to in this whole chapter as the present value. It's how much you deposited or how much you borrowed on day one. That's why it's called the present value. As of the day that you sign the loan papers or the day that you make the deposit into the account, that is your present value of the amount in your account. R is an annual interest rate, and that's how it's going to be stated through this whole chapter. R will be given as the annual interest rate. If you have interest rates that are compounded other than annually, you're going to have to use that interest rate adjusted by how often it's compounded. But R is the annual interest rate, and it must be expressed as a decimal. The only exception is when you use the TVN solver on the calculator, you can enter the interest rate as a percentage. It will calculate it as a percentage. And T is always the time in years. So here's our first example. To buy furniture for a new apartment, Pamela Shipley borrowed $5,000. That is her present value or her principal at 8% simple interest. You have to watch for those words, simple interest. At 8%, so her interest rate expressed as a decimal is 0.08 for 11 months. So she didn't borrow it for a whole year, she only borrowed it for 11 months. So for that reason, her time is 11 over 12 because there are 12 months in 1 year. So when your time is not given to you as a specific number of years, you're going to have to adjust that. So depending on how it's given to you, you need to know that a year is 12 months, 52 weeks, or 365 days. And the question that we're asked here then is, how much interest will she pay? And the way that you calculate that formula is just substitute in interest equals principal times rate times time. So that means since our principal is $5,000, and our interest rate is 0.08, and her time is 11 months, you put in 11 divided by 12. There's no need to change that to a decimal. And then you hit the calculator. So this is the part where you're just going to do some arithmetic. So that means the amount of her interest that she's going to pay, and this is always going to be rounded to, since it's money, we're going to round it to the nearest cent. So the amount of interest that she's going to pay is $366.67. So she will pay $366.67 in interest. Now, some other questions that we might ask or might answer based on that. The total amount that she will repay is going to be the $5,000 plus the $366.67. So that's the total she pays with the interest and the principal. And all you're doing to get that total amount is you're adding the amount that she borrowed to the amount of interest that she had to pay. That was her rent for borrowing the money. She basically rented that money. And then if she made monthly payments, then her monthly payment amount would be the $53.66. So I'm going to take this and add her $5,000 that she borrowed, and then I'm going to divide that, since she was making 11 months. She was borrowing for 11 months. If she paid monthly, she would make 11 payments. So each one of her payments would be $487.88. And even if she paid the loan off early, even if she made double payments every month, she still has to pay that amount for her payments. There is no advantage to prepaying or paying off a simple interest loan faster. She still has to pay the same amount ultimately.
If she paid it faster though, wouldn't she not have as much interest because the interest would...
They charge you all the interest up front with simple interest. There's both advantages and disadvantages to simple interest. The advantage is because they compound it over the whole entire life of the loan, and you don't have to pay interest on your interest as you go along, then actually your payments are cheaper and the total amount that you repay is cheaper. There is no advantage to paying it off early because they charge you all of it up front. They tell you this is what your monthly payments are, and it says in your paperwork that you sign that the total amount to be repaid is this much, and it doesn't matter that you pay it early. Okay, I mean, that's kind of the trade-off. Anybody have any other questions on this one? See if I can get this first. Okay, let's look at another one. And again, we're going to talk about some maturity values. And I actually kind of already talked to you about this. I went ahead and kind of gave you a preview of coming attractions. So, probably can see this better if we just go ahead and maximize this.
What page you on that?
Should be still on the first page, maybe the second page.
Oh, yeah.
So the future value is called the maturity value. And for some reason, known only to the people that make up these formulas, the future value or the maturity value is always used as F. It's called A for some reason.
I think it's related to the fact that this is the future value of an annuity. Because what people do is they want to have an annuity where they will make payments for a number of years and have a large amount of money in the bank, hopefully when they get ready to retire and be able to draw against that. But the future value, as we just saw in the last one, this is your principal, or the present value. And then this formula is simply the simple interest rate formula. But what they've done is they've taken the principal and added the simple interest to it and then factored out the fact that you have a P in both of those and put it in front, so it actually is easier to work this way than it is to do it this way. But it's the same thing, it's the same calculation. So this part actually comes from your principal times rate times time, which is your simple interest formula. So that amount is called the future value of P dollars at an interest rate R for the time T in years, and when loans are involved, the future value is often called the maturity value of the loan. If it's a loan, they call it a maturity value. If it's a savings account, they call it the future value. Well, here's an example for a maturity value. Find the maturity value, which is A, for each loan at simple interest. And the key here is you have to keep looking for the words simple interest. You have to see the word simple in front of interest for this to work, because that's the only time you use this formula. So here's your present value. You take a loan for $2,500. You're going to repay it in 8 months. So your time is going to be 8 over 12. And no, I don't care if you reduce the fraction. 8 over 12 works just fine because we're going to put it in the calculator. And then your interest rate is 4.3%. And since we have to have that as a decimal for simple interest, then we're going to use the value of R is 0.043. Don't forget how to change your percentages into a decimal, and that's part of the skills review. That's part of your chapter.
Places to the left, right?
Hmm?
You just move it 2 places.
Move it 2 places to the left. But if you don't remember that, you need to practice that, and then you're going to need to do the skills review homework to get yourself into that habit. So now we're ready to actually calculate the maturity value.
okay? So the maturity value, A, is going to be equal to that $2,500 times 1 plus the interest rate, which is 0.043, times the time, which we're going to enter in the calculator as 8 divided by 12. So we'll get the calculator. And enter $2,500 times 1 plus 0.043 times the time, which is 8 divided by 12. Always put your time, if it's in months or in days or something like that, put that in parentheses. Fractions always go in parentheses. So that should correspond to our formula on the previous page. So that's this formula. Okay? I will give you the simple interest rate formulas on the test, but you won't need a lot of the other formulas. So once we do that calculation, the total amount that she's going to have to repay is $2,571.67. And the reason that that total amount is what it is because the original amount she borrowed was the $2,500 plus the amount of interest that she's going to pay on that $2,500 at that 4.3 interest rate for 8 months. The total amount of that is only $71.67. That's the total amount she repays. And again, if we wanted to know her monthly payments, we would just divide that by 8. And I say her, that's where we started from. Okay? Any questions? This chapter should be the chapter that's probably the most interesting for all of you because at some point in time, everybody in here is going to buy a car. You probably at some point in your life are going to need to buy insurance. You're probably at some point in your life going to buy a house. You're going to save for your retirement, hopefully, because it doesn't look like Social Security may be around for much longer. You never know. So you always want to have a backup plan. So all of these problems that we're going to do in this chapter should be problems that you're going to actually encounter in your life, even if you weren't a business major. So part B says find the maturity value, which is A, for a loan of $11,280. Maybe somebody bought a car. That's your present value. And your time, this time, is only for 85 days. So the time expressed in a year is going to be 85 over 365.
Do you always express time as years in these programs?
You have to. Because when it's simple interest, it's always the interest rate per year. It's always compounded per year. And this is not a whole year. Okay? And then your 7% interest rate is R equals 0.07. So when we get ready to find the maturity value, then we just use that formula one more time. That's going to be your principal times 1 plus the interest rate times the time. And on the calculator, this is always going to be written out as 1 plus 0.07, and then it's 85 divided by your 365. I try to always give you the calculator steps so that you'll get your parentheses in the right place. So $11,280 times 1 plus 0.07 is the interest rate times 85 over 365. So the maturity value for this loan is $11,463 and 88 cents. And the maturity value is the amount that you're going to repay. So even though you have a higher interest rate, since that's a much shorter time period, then your interest rate's just shy of $200.
Does that say at the bottom there, the maturity value, what? Oh, it's the amount.
Amount to be repaid. Any questions? Okay. Now we're going to talk about something that's a little bit different. This is no longer simple interest, although simple interest is kind of involved. This is going to be the formula for compound interest, which means that your interest is not simple interest charged for the entire period of the loan all up front. With compound interest, you'll have your interest compounded more often than just once a year. For example, the number of compounding periods per year may be semi-annually, which means twice a year. Or it may be quarterly, which means 4 times a year. Or you may have it compounded monthly, so it will be compounded 12 times a year. And then T is going to be the number of years. Your annual interest rate is R. But since it's going to be compounded more often than once a year, then you're going to divide that interest rate by the number of compounding periods in each year. So for example, if your interest rate was 8% and you're going to compound semi-annually or twice a year, then every time they compound your interest, which is going to be every 6 months, then they're not going to charge you the whole 8%, they're going to charge you 4% because it's twice a year. So I is actually the annual interest rate divided by the number of compoundings per year, and it's your interest rate per period, per compounding period. And the value of N then is the number of compounding periods, which is the number of periods per year times the number of years. So semi-annually, if it was 8 years semi-annually, then you would actually be compounding 2 times 8 or 16 times. And the best way to see these is to actually work it out with an example. So we're going to go from here to an example. It says, suppose that $1,000 is deposited for 6 years in an account that pays 4.25% per year, but it's going to be compounded annually. Compounded annually means once a year. So your actual time, going back to the formula here, your actual time is 6 years, but you're going to compound it annually, so you're going to compound it 6 times. So T is the number of years, but N is the number of compounding periods, and N is the number of compounding periods per year, so it's actually, in this case, times once a year. So the value of N is actually 6.
If you were doing that like quarterly, you would just put 6 times 4.
6 times 4. Or if you're doing it monthly, 6 times 12. Okay? But this time, the first one, we're doing it annually. Okay? And that also tells us that our interest rate, which is 4.25%, we're going to call the compounded interest rate R divided by M, the number of compounding periods. So in this case, it is 0.0425, but since the number of compounding periods is 1, then it's the same as the annual interest rate. So it says find the compound amount. The compound amount is A, the future value. And our present value, P, is $1,000. So I'm going to make a note of what the formula is. And then we're going to fill in everything. So P is $1,000
What
times
does
1.
that formula say? A equals P, 1 plus...
P times 1 plus I for the interest rate.
And then N squared.
No, just N.
N.
Just N. So P is our $1,000. Our interest rate, which is this, is 0.0425. And then the power on the outside is going to be the number of compounding periods, which in this case was 6. So we're going to calculate A. 1,000 times 1 plus 0.0425 raised to the power 6. So then our compound amount is $1,283 and 68 cents. Okay? And then it says find the amount of interest earned.
Just a subtract that. Just do subtraction.
You just do a subtraction. You subtract P, what you started with. So the amount of interest earned is going to be $283.68. Questions so far? Okay, let's play a little what if. I'm going to change one thing. What if I didn't compound annually? What if I compounded monthly? What if I compounded monthly? What would change? N's going to change because N is going to be 6 years times 12 months. So N is going to be 72. What else changes?
Your interest rate.
Your interest rate is going to change. It's going to be the annual interest rate, but it's going to be divided by 12 for once a month. So instead of being 0.0425, it's only going to be 0.354% per month. Now, we're not going to do that calculation up front. We're going to include it in the problem. So I'm not going to actually do the substitution. I'm going to include everything in the problem to make sure you know where everything came from. So in this case, our compound amount, A, is still going to be my $1,000. Same amount of money. And I'm still going to have 1 plus, but my interest rate now, because this came out to be such a big, long, ugly decimal, and I don't want to round off, I'm actually going to put in that interest rate as 0.0425 divided by 12. Okay?
What are you doing by dividing? Put a parenthesis 1 plus 0.0425 divided by
12. And actually, you don't have to have these parentheses. It will work, but get in the habit of putting them in anyway, because there will be cases where it won't work if you don't use parentheses around your fractions. And then when you do your power, I'm going to suggest that you do the same thing. Rather than letting your head say, oh, 6 times 12 is 72, put in 6 times 12. Don't make any mistakes that way. So your formula now looks like this. Just by changing the compounding period. So when I clear this out and redo the problem, I'm going to have 1,000 times 1 plus the interest rate, 0.0425, divided by 12 months in a year. Close those parentheses and then close the ones that were in front of the 1. You open 2, so close 2. Raise it to the power, and then put your new power, that is 6 years, times 12 times each year. And your future value now, your compound amount, is $1,289 and 88 cents. Compared to compounded annually. So did it cost you a lot of money because they compounded monthly?
When I did it on the calculator, I got 20,000. I got over 20,000 and I did it the same way you did.
Okay, and logic tells you that couldn't possibly be right.
Wait a second, I realized what I forgot to do. I put a 0.0425 divided by 1.
Oh, okay, yeah. So what you actually calculated was compounded annually for 72 years. You would have a lot of money if you'd actually had it left it in there 72 years. Okay, but by compounding monthly, did it actually gain you that much money? Did it really change your amount that much? Not really. Okay? So it didn't gain you much. Now the interest rate, if it was a different interest rate, it might be very, very different. But the point here is that this is more. Now how much more? Well, let's see.
It's about like $6.
Yeah, it's just about $6. So you got about $6.20 more in interest, okay, by compounding monthly.
Is there a calculator thing to solve compound interest?
There is, and we are going to learn how to use it, but I want you to understand the process. Because identifying these things, that's the hard part, okay? So the amount of interest.
Let me make sure I got that wrote down. You say one, I put it in there right, and I got the answer. You say 1,000 parentheses, 1 plus.
Another set of parentheses,
Okay.
0.0425 divided by 12, and then close both sets of parentheses before you do your power, okay?
Got a parenthesis inside of the parenthesis.
Okay, let's do another example. Get all your notes, Cole?
Yeah.
This one says, find the amount of interest earned by a deposit of $2,450 for 6.5 years at 5.25% compounded quarterly. Okay? They only want the amount of interest. So ultimately, we're going to take the future value and subtract the present value. So even though it only asks for the amount of interest, we're still going to have to find the future value to be able to get that. So our future value, A, is equal to the present value $2,450, times 1 plus, and now we need to calculate this is actually called the periodic interest rate. So the periodic interest rate comes from two things. It comes from the annual interest rate, and then by how often you compound. Which is 4 times a year. Then you need your power. So they're going to compound this for 6.5 years. So there's the number of years. But they're going to compound it 4 times in those 6.5 years, 4 times each year. So there's the calculation we're going to type. So the compound amount is going to be $3,438 and 78 cents. And to answer the question about the amount of interest, we'll subtract off the principal. So the amount of interest is actually $988.78. Now make sure you're able to pick out all of the different pieces of information that you need to pick out for those problems. Any questions? Okay. Now we'll talk about the calculator. When we do a problem on the calculator, these are the things that you're going to need to be able to pick out of the problem. So every time you start a problem, once you start using the calculator, you need to be able, pick out all of these different values. One of these will be something that you don't know, and that's what you're going to have the calculator solve for. You may not know the annual interest rate. You may not know the payment. You may not know the payments, well, you are going to know the payments per year and the compoundings per year because that has to be given to you. You may not know the present value, you may not know the future value, but you'll need to be able to pick out all of those things. Now, this is for the TI 84 Plus C, the newest one. The little thin one that looks, has a really bright screen and it has colors. The TI 83 has the same app. What you need to look for on the TI 83 is that word finance that's written under the math key. That's actually above the X to the -1 key. So in order to get to the apps menu for finance, you're going to hit second and X to the -1.
How do I do it on this one? You just go to apps, on the second apps or something?
Yeah, I was going to ask you what yours does, because,
I just have to get.
Just do it in this business class, but I forgot how to do it.
let me see yours for a
There it
second.
is.
Second
Finance.
and second one is in interest.
Just hit apps, hit finance. Yeah, TVM solver. Yeah,
Okay.
there it is.
So, does anybody have an 84 and you can't find it? Because the 84 is different, and it depends on which 84 you've got. If you've got one of the earliest ones, it's located one place. If you've got one of the newer ones, but not the C, then it's in a different place. So look and make sure that you can find the TVM solver on your calculator. Is anybody not finding it? Now, I'm going to remind you all of something. You cannot use the one on the computer on the test. You're supposed to have a handheld calculator. You can't use your cell phone, you can't use the one on the computer. If you're going to need to borrow one, be sure you do that before the test. Be sure it's compatible with what the one on the computer is, because you're not going to have computer access and no cell phones. Okay, once we find the TVM solver, and that's really, we're going to use actually a couple of other options on this, but that's the main one. We're going to go to the TVM solver and press enter. Now the thing to keep in mind here, and this is the only hitch to being able to use this. You have to know when you need to do certain things. The TVM solver uses something called cash flow sign convention. You may have talked about this in accounting, you may have talked about it in maybe a different class. But what we're talking about is the direction of the cash flow. Are you paying in, or are you paying, is it paying out? Are you putting money in, or are you receiving money? Cash inflows are entered as positive numbers. Cash outflows are entered as negative numbers. So if you're putting money in, you're actually doing a cash outflow. So if you invest money, the present value is the amount you invest, and it is considered an outflow. So your present value will be put in as a negative, because it is money you deposit. Now, if we're talking about a loan, then the present value would be put in as a positive, because you're getting it back. You're actually getting the money. It's money coming to you. But if you're making an investment, then your present value is going to be put in as a negative. The future value is the money you will receive. So if it's the money you will receive at the end of an investment, and the key is that it's going to be at the end of the investment, it's considered an inflow, and therefore it is a positive value. Now the difference is, if you're borrowing money, the present value is money you'll receive, so it's an inflow. It's an inflow, and it's going to be positive. The future value is the money you pay back. calculator out of the way. So it's going to be considered an outflow and therefore a negative value. So the first thing you need to notice, and the problem is this an investment or is this a loan? Because it's going to make a difference on your signs. I'm going to keep this handy. We're going to look at example 5, the one we just did. Find the amount of interest earned by a deposit of $2,450 for 6.5 years at 5.25% compounded quarterly. Is this an investment or is it a loan? It's an investment. So because it's an investment, we're going to enter the present value as an outflow, and therefore it's going to be negative. Now, some other things to take note of. We're going to let the payment equal 0. Because we're not recipients. And we're not making any more payments once we make the initial investment. We're only going to invest the initial $2,450. We're not going to add more to it as time goes on. If we did, it would become an annuity. But if you only deposit a lump sum up front and leave it alone, it's not an annuity, it's just a regular investment. Now the future value is going to be set equal to 0 also, even though we know that that's not actually what it's going to be. We're going to set it equal to 0 because we're going to need to solve for that.
You gotta leave the cursor on the one you want to solve.
You have to leave the cursor on the one you want to solve. And in this particular problem, by looking at your compounded quarterly, that tells you payments per year and compoundings per year are both equal to 4. That's why you have that. It's because you're quarterly. Okay? Yes?
Are your payments and your compoundings per year always going to be the same?
They always have to be the same. They always have to equal each other.
And your calculator, you're going to find out, is really helpful about that, because when you put in P/Y, it automatically puts that same number in C/Y. So it's not going to let you mess up. If you try to change it, it's going to change it back.
When would we change that? I remember you don't change that very often,
What,
the bottom two.
the bottom one, when we get to annuities.
Okay, so when do we use 4, like when we're doing monthly stuff?
No, this is compounded quarterly.
Yeah,
These two are compounded quarterly.
okay.
Right now, don't worry about this bottom.
When you're
Okay?
doing annual, you do 1.
You do 1. If you do it daily, you do 365. If you do it monthly, you do 12. Okay?
Where this one here is month, or quarterly.
Right. Okay, now once we get everything filled in, when you want to find one of those values, in this case we want to find the future value, you're going to have to put your cursor on the future value. And then you're going to enter alpha and solve. Alpha and solve is on your, let's see if it's the 83.
It's alpha.
It's alpha, this key right here, and then it's enter. So even though it says alpha solve, you're actually doing alpha and then hitting the enter button, and it will solve.
And we're solving for future
and you're gonna solve for the future value. Okay? So let's see if we can get this problem in here. Now, N, remember, is the number of times that you're going to compound. We're going to compound quarterly, so that's 4 times 6.5 years. You don't have to do this arithmetic separately. It'll do that for you. Okay? The interest rate you can put in as a percentage. A percent, not a decimal. That's different from the way you do it if you're doing the arithmetic. Your calculator will actually move the decimal for you. So put it in as a percentage. Your present value, remember that that's the money that you're paying out in the beginning, so it needs to be negative. You're not making any payments, you're making that one-time lump sum payment, so payments are 0. Set your future value to 0. Don't worry about what's at the bottom until I tell you that we're doing a problem where we need to worry about it. That won't be in this section. So enter your future value as 0 and leave your cursor there. Press alpha, enter, and it will tell you what your future value is. And you just need to round appropriately. So this is the exact same answer we would have gotten before. Okay? No plugging in formulas, no working any arithmetic, no remembering parentheses. Tell the calculator what the values are in the problem. It'll do the arithmetic for you. So all we need to do is practice. Now there are a couple of cautions, and you can kind of ignore this because I'm not going to talk much about this. Compound interest problems involve 2 rates, the annual rate and the rate for compounding period. Remember, you're going to need to be able to actually put in your annual rate and leave it alone. If you're compounded annually, then that rate's going to be the same because your interest rate it is going to be the same as I. But in all other cases, it's not. So you have to have the quantities for time, which is T, and the number of compounding periods N, and then your calculator, once you give it the right information, your calculator will adjust and find I. Notice nothing on that screen asks you for R. It just says interest rate. So it doesn't ask you to make a distinction. You're going to put in whatever the stated interest rate is. You're not going to adjust it. You're going to let your calculator adjust it. Now what happens, so that you have an idea of the difference between simple interest and compound interest, if you invested $1,000 at 1% compounded annually, at the end of your compounding, your future value would be $2,500. But if you had compound interest at the same interest rate, but it was compounded okay, this is for 20 years, sorry. So simple interest says at the end of 20 years, your $1,000 has become $2,500. Your compound interest says, what if you compounded your interest annually? How much would you have at the end of your 25 years? Look how much more you'd have if they compounded your interest every year. Because what's happening is you're getting interest on interest that was already paid to you. So it grows a lot faster. Now on the negative side, if that's a loan, your payoff is a lot higher. So let's do one more example before we move on. And we're going to use the calculator. So I'm going to get it up here, but I'm going to try not to cover everything up. So Susan invested $5,000. That means her present value is going to be negative because she paid in that $5,000. In a savings account that paid quarterly interest, that means P/Y and C/Y are both going to be 4. After 6 years, so her number of years is 6. My calculator turned itself off. So after 6 years, so that's going to influence N. It's going to be 6 times 4 for the compoundings. The money had accumulated to $6,539.96. That's her future value. So the question that they're going to ask us now is not one that would be easily arrived at if we had to actually calculate this formula ourselves. It would be very frustrating. What was the annual interest rate? Okay? So here's how we're going to ask, we're going to put the problem in here. Compounding is 6 years times 4 times a year. The interest rate, we have no idea, so we put in 0. The present value is negative 5,000. Number of payments, again, is going to be 0. She only made that initial deposit. She didn't make any payments. The future value is 65, 39, 96. Compoundings per year and payments per year is 4. Now, if I change that to 5, notice as soon as I move down, it changed CY to 5. So when you enter 4, it'll automatically adjust to make sure those are equal. They're always going to be equal. So then you take your cursor back up and you put it on the interest rate. And you hit alpha, enter, and it says the interest rate was 4.5. Okay? And like I said, that would not have been an easy problem to solve,
if we had to solve it using arithmetic. We haven't learned the techniques yet that we would need to be able to solve that. So that's where we're going to stop for the moment. We're going to come back next time, talk about present value, but from this point onward, we're going to be using the calculator. I'm going to go ahead and finish this lecture and put it in Shobi. So when I do that, I want you to go ahead and fill in your notes, for example, 8 and 9 and 10, because I'm going to be showing you how to use the calculator. So go ahead and finish your notes for section 5.1, and then do the problems for section 5.1 and show you. Yes. Okay, hang on just one second. I'll come.